In this session, we will look at the domain and range of various trigonometric functions. That is, the possible values that an angle could take and the values that the trigonometric ratios could take. Now, let us look at these two axes shown here. Let's label them as x and y, and let us define the origin as O. And now one can think of various kinds of angles. So one can, for example, think of an angle theta as shown here, which is of a particular value as measured from the positive direction of the x-axis. So this is the positive direction of the x-axis, and we can see that the angle theta here can be measured from the positive direction of the x-axis in the counterclockwise direction, that is this angle that is shown here. Or alternatively, this angle can be measured from the positive direction of the x-axis in the clockwise direction, like this, which we know is 2 pi minus theta. Now, by convention, we measure angles from positive x-axis in the counterclockwise direction as positive. So all the angles that will be measured in this direction will be measured as positive, and angles in the clockwise direction as negative. So all the angles measured in this direction would be negative. Therefore, if this angle theta is 30 degrees, we will call it plus 30 degrees or plus pi by 6. And we don't have to show the sign plus in case an angle is positive. Now the same angle can be measured from the negative direction as minus 330 degrees, because 360 minus 30 is 330. And we can also write this in radians as minus 11 pi by 6 radians, because 2 pi minus pi by 6 is 11 pi by 6. Therefore, what we have seen is that the angles pi by 6 radians and minus 11 pi by 6 radians refers actually to the same angle. Now, in a similar way, we can draw an angle something like this, which is, let us say, 60 degrees from the positive x-axis measured in the clockwise direction. So therefore, we will call it minus 60 degrees, which is same as minus pi by 3 radians. And the same angle can be measured from the positive x-axis in the counterclockwise direction, like this, as plus 300 degrees, because 360 minus 60 is 300, which can also be expressed in radians as 5 pi by 3 radians, because 2 pi minus pi by 3 is 5 pi by 3. Therefore, an angle of minus pi by 3 is equal to 5 pi by 3. Therefore, we have established that any angle theta is equivalent to an angle which is negative of 2 pi minus theta, which is equal to theta minus 2 pi. Now let us again look at this angle theta and say that it is equal to pi by 6, that is 30 degrees. And now if we add another 2 pi radians to this angle, it will basically amount to rotating this line, which makes an angle of pi by 6 with positive x-axis, by an angle of 2 pi, which is one full round, one full circle in the counterclockwise direction. Therefore, by adding 2 pi radians to theta, we come back to the original value of theta, and therefore we can say that pi by 6 is also equal to pi by 6 plus 2 pi, which is 13 pi by 6. Therefore, we now establish that theta is also equivalent to theta plus 2 pi. So we basically see that if we add 2 pi to an angle or subtract 2 pi from it, we basically come back to the same angle. And you can now intuitively see that this holds true if we add any multiple of 2 pi or subtract any multiple of 2 pi from an angle. Therefore, we can conclude that any angle theta is equivalent to that angle plus or minus n times 2 pi, where n is an integer. Now let us try to